So we're given the task of designing a frisbee launcher to launch a 4 centimeter diameter, so a 40 centimeter diameter is equal to 0.4 meters, and that gives us a radius of 0.2 meters. So we have a mass of 0.6 kilograms, and it's a flat circular disc. So that gives us a moment of inertia, which is equal to 1/2 mass times radius squared. And then we have a linear acceleration of 20 meters per second squared, and then an angular acceleration of 50 radians per second squared. So we're going to write our equilibrium equations with, we're going to note that the C point is the center of the frisbee, the y-axis is acting up, and the x-axis is acting to the right. So our net forces in the y direction are going to be what we want to focus on. So we have force 1 plus force 2, and that is equal to mass times acceleration. So our mass is 0.6 kilograms, and our acceleration in the y direction is 20 meters per second squared. Okay, and this gives us force 1 is equal to 12 minus force 2 when we simplify this out. So now we want the net moment at point C, and that is going to be equal to the moment that's created by force 1, which is going to be negative, and we have a radius of 0.2 meters times our force 1, that's the moment, plus the moment created by force 2, which is 0.2 meters times force 2, because if you remember, moment is force times the radius. And then that is equal to our I times angular acceleration, which is equal to 1/2 times 0.6 kilograms times 0.2 meters squared times our angular acceleration, which is 50 radians per second squared. So from here, when we simplify this, we get negative 0.2, and we're going to want to plug in force 1 we found from our net forces in the y direction. So negative 0.2 times 12 minus force 2, which is equal to, and that we have a plus 0.2 times force 2, which is equal to 0.6. And that's just this simplified. So from here, we get 0.4 force 2 minus 2.4 is equal to 0.6. And we get that from simplifying this and combining like terms. And that gives us force 2 is equal to 7.5 newtons. And then from here, we can plug our force 2 back into this equation to get our force 1. So we have force 1 is equal to 12 minus 7.5. And this gives us our force 1 is equal to 4.5 newtons. And those are our force 1 and force 2s that we want in our initial situation.